Hello everyone, welcome back to our channel. I hope you all are doing well. So we are back with one more problem that is there in Blind 75 SDE sheet. So we will be solving that today. The name of the problem is set matrix zeros, right? It is very straightforward problem. So let's read the problem statement. We have been given an m cross n integer matrix. If an element is 0, so we have to set its entire row and column to zeros, right? So we can see from the example, like it is very clear, like if we have any 0 in any row or column, we have to convert that particular row and column to 0. I'm showing you by the pointer as well, like here here in there is 1 0, right? So we can do it, we have what we have to do is basically, if we have any 0, so what we have to do, we have to modify this complete row and complete column with 0. Okay, you can see the resultant matrix, that is, it is getting modified with 0 from both ends. Similarly, we can see in example 2, here we have 0. So as we have tackled 0 at the first index only, so we have to convert this particular thing to 0 and this particular columns to 0. Okay, we can see here. And also we have tackled the 0, so here also this thing we have to convert to 0 and this thing also. So that's a straightforward question. Let's see the approaches, and first of all we will go through the constraint. So basically we have constraint very common, like matrix dot length n is equals to matrix dot length, and basically the order of matrix. Here we can see this is 3 by 3, here it is 4 by 3. So here 1m should be greater than equal to 1 and less than equal to 200. Okay. Also matrix ij, the size of it must be greater than equal to minus 2 to the power 31 till 2 to the power 31 minus 1. So what can be the brute force approach to solve this question? So a nice solution, one can think of it basically quite obvious, like first of all what we will do, basically we have been given this matrix, so we will make a copy of this matrix, and we will compare all the zeros. If we found any 0, we have to modify that particular row and column. We can see here, basically we have to use a copy of the original matrix to mark which rows and columns should be set to 0. Okay, we have to traverse the matrix again, and wherever the copy has a 0, we have to modify the original matrix, sorry. And like it's steps I have broken down in the steps. So we have to create a copy of the matrix, we have to traverse the original matrix to find all zeros and mark their rows and columns in the copy. Okay, after that we have to traverse again and set the elements to 0 in the original matrix based on the marked copy. Okay, so for this approach, the time complexity we have is basically O of m cross n plus O of m cross n. Okay, so since we are traversing the matrix 2 times, so it will be twice. And the space complexity is also O of m cross n, since we are using the copy of the matrix. Okay, so this extra space, this requires the extra space, so basically the space complexity will be O of m cross n. So this is obviously the inefficient because of the extra space we are using here. Let's think of the optimal approach. I will be sharing with you all what can be done. Basically in this question what I have done is basically this question has 3 approaches. First is brute force, second one is optimized but not the fully optimized, that we can say optimized version is basically the better approach. So let's look at the better approach first. So instead of storing the entire matrix copy, we are using 2 arrays to track which rows and columns should be set to 0, right? So if we are using 2 arrays, what we will be doing is basically we are using 2 arrays, row and column of size m and n, to mark which rows and columns should be set to 0. Traverse the matrix, we have to traverse the matrix, basically we have to fill the row and column arrays based on the where zeros exist, right? And we have to traverse again and set elements to 0 using rows and columns. Similarly, time complexity will be 2 times O of m cross n, space complexity will be O of m plus n. This is obviously the better approach than the brute force, but the most optimized approach that I am really interested to telling you all is basically basically O of that will be taking O of one space. So what we are doing is, our idea is to reduce the space, right? So we have to use the matrix itself as a storage, right? Instead of extra arrays, we use the first row and first column as markers. So first pass is basically identifying the zeros and mark corresponding first row and column, right? Second pass is basically use these markers to set the respective rows and columns to 0. And we have to handle the first row and columns separately at the end. And basically the time complexity for this will be O of m cross n. And space complexity will be O of 1, right? Explanation of code is basically, we have to, first of all, I will not tell the explanation. Let's see the code first, okay? It's easy. You guys don't need to worry about 2D matrix things. Basically, I think many people think having some difficulty to solve matrix problems, but literally it is quite simple if you try to think in a simple manner. Like, I have broken down into the steps. Basically, first of all, what we have to do, we have to identify if the first row or the first column needs to be 0, right? For this, we are putting into a for loop, and we are making a condition like if matrix I0 is equal to 0, right? Okay, then we are again using a for loop. For this was for basically checking for column 0, and this is for checking the row 0. Okay, similar things happening, but for row and column separately. Okay, for step 2, what we are doing is basically we are using the first row and first column as markers. Okay, here we are taking the row, marking the row, and here we are marking the column. After that, we have to use the markers to set matrix elements to 0, right? So this is the condition for this. Okay, and step 4 is basically handling the first row and first column separately, right? After that, it's quite simple. We are not doing anything. Since the function is like void, we don't need to return anything. It's self-sufficient, self-explanatory. So this was the coding part, and explanation for this code is basically in the 4-step, very crisp. Like, basically what we have to do is we are checking if the first row or first column should be 0, and after that we have to use the first row and column as the flags for marking rows and columns to be set to 0. After that, we are updating the matrix based on these markers and handle the first row and column separately to avoid premature overwriting. Although the time complexity is not getting reduced, it is as same as the brute force, but main thing, that is the space complexity is getting reduced to constant because we are making the matrix itself as a storage, right? So I hope I was able to clear the explain the approach to you all. If you guys understood the solution, please hit the like button and also share it with other students as well. Thank you.